Air pollution is associated with black particles, which is often seen on windows, leaves and buildings in towns and cities around the UK. However, much of our air pollution today is invisible. Some air pollution you can smell from car exhaust factories and farmyards, and what we're really interested in is the changing concentration of nitrogen in our atmosphere. This can have important impacts on living things by stimulating the growth of some and inhibiting the growth of other species. Air pollution is found from industry and roads, which produce large amounts of oxides of nitrogen and microscopic particles. So it's really high in urban areas. On the other hand, ammonia is associated with agriculture and can be found predominantly in the countryside. So we want you to start thinking about air pollution. It's essential for the health of our natural environment and of ourselves, and has impacts on food supply, water quality and biodiversity. And you can do something about this. And this starts with our OPAL Air Survey.
The OPAL Air Survey uses biological indicators to monitor air pollution. Now, these can be any species that are sensitive to environmental conditions. Some species of lichen are well known for their sensitivity to air pollution. A lichen is a combination of two organisms, an alga, which provides the food, and a fungus that provides structure. And it's these different structures which makes lichens more or less sensitive to air pollution. The more bushy the lichen, the more sensitive they are. Now, for the OPAL Air Survey, we're using 9 species, and these are either sensitive, nitrogen-loving, or occur in both environments.
The Air Survey pack contains a fold-out chart, a workbook, a tree chart and an OPAL magnifier. When you go, you'll also need to take a tape measure and a pencil to fill in the workbook. Use your tree guide to find a suitable tree and begin the survey. Fill in the workbook starting with a site description, noting down what you can see from the options available. Measure the girth of the tree at about 1 metre above the ground. Use the pictures in the chart to identify the indicator lichens if present. You can use an A4 sheet of paper to estimate coverage of each of the indicator lichens, using the fold-out chart as a guide. 1 is less than 1/4 of a sheet of A4, 2 is between 1/4 and a whole sheet of A4, and 3 is an area greater than a sheet of A4. OPAL scientists are still very interested to hear if your trees do not have any lichens on them. This tells us lots about the local environment. The 9 lichens we've chosen are useful bioindicators, but you may see other species of lichen. Record the number of other lichens you see in the workbook. Also make a note if orange or green algae are present on your tree, and then take the time to note down any other creepy crawlers you come across. If twigs are within easy reach, look for indicator lichens. Avoid dead or fallen twigs and only use twigs that are less than 2 centimetres in diameter, and just look up to 1 metre from the tip. Be careful not to get twigs in your eyes. Record each indicator lichen present with a tick or a 0 if absent. Again, note down if algae is present. You may get a different result from the younger twigs, as tree trunks may carry a legacy of pollution. If you would like to upload photos of the lichens you find, or would like help to identify them, follow the instructions on the OPAL website. That's 1 tree done. Find another 2 to 3, preferably of the same species, and off you go.
Tar spot on sycamore leaves is caused by the parasitic fungus Rhytisma. This fungus overwinters in leaf litter on the ground and reinfects the trees in the springtime. It causes these characteristic black spots on the leaves, and the fungus is sensitive to oxides of nitrogen and sulfur dioxide, which are found in air pollution. So the more spots you find in an area, the cleaner the air is in that area.
The second activity looks at tar spots on sycamore trees. This is an independent survey, so you don't have to do them all in one go. The first step is to use your tree ID guide to find a sycamore tree. Note your location, describe your site, and see what's around you. Look under your tree for fallen leaves and give them a score. 0 means there's no fallen leaves, 1 means there's a small amount of fallen leaves, and 2 means there's lots of fallen leaves. This is important since the fungus overwinters in the fallen leaves. Choose 10 leaves at random, but don't pick them off. Measure the diameter at the widest part. Count the number of spots, including partial spots, and record them in your workbook. When you've done either or both surveys, upload your results at www.opalexplorenature.org. There's a map on our website to assist you with locating your site. Activities 1 and 2 give us new information about species that are sensitive to 2 different types of air pollution: ammonia, which is mainly from agriculture, and oxides of nitrogen, which is mainly from traffic and energy generation. For lichens, when you enter results on www.opalexplorenature.org, a score is calculated which can be compared with a national scale. When there are plenty of nitrogen-sensitive lichens on tree trunks, there is likely to be no intensive farming, dense traffic, or heavy industry. In contrast, in areas where nitrogen-loving species like Xanthoria and Physia are abundant, levels of nitrogen-containing pollutants are likely to be higher. High numbers of tar spots on sycamore leaves may also indicate relatively clean air. More information about what your results mean can be found in the accompanying workbook. If you would like help with lichen identification, visit the iSpot website, www.ispot.org.uk, or use the links on the OPAL web pages.